Hello, my name is Dr. Roderick L. Roll, and today I will be talking to you about chemical control of microorganisms. Germicides destroy microorganisms on medical and dental instruments that cannot be sterilized with regular steam or heat. One example is a plastic tube. A germicide can be used on a plastic tube. These germicides affect growth by disrupting the cell wall, the cytoplasmic membrane, the structure of proteins, and the structure of DNA. In this image below, we're looking at the cell membrane. To the right, the membrane and the wall has been punctured, therefore letting water come in or water to come out. These germicides, which are also disinfectants, can be placed into three groups based on how effective they are at killing. The high category will kill microbes that are most resistant to disinfectants. These disinfectants will be used on items that may be placed inside the body and left there or used inside the body. So in this image, we're looking at a cadaver where the chest cavity has been opened. In this cavity, we have some plastic tubes to suck out the blood as they are operating. Those plastic tubes were disinfected with a chemical that is in the high category. To the far right, you see a plastic structure that they're used to drill into or to anchor a tooth into the gum fossis joint. That anchor might be a plastic-based material. That material is sterilized by some kind of chemical that is placed into the high category. The intermediate category of chemical agents will be used on items that touch a membranous membrane, such as the vagina or the oral cavity. So if a tracheotomy is performed, the plastic tube that is inserted into the trachea must be cleaned. It will be cleaned with a disinfectant that falls into the intermediate category. The low category of agents are used on anything that touch skin. Items include furniture, electrodes, and the sphygmomanometer. We are now going to discuss each one of these chemical methods. All of these disinfectants or germicides can be placed into 7 groups based on their chemical composition. The first group are called the alcohols. The alcohols will fall into the intermediate category of germicides. These alcohols will disrupt protein and cytoplasmic membranes. Alcohols will evaporate. This is a good and a bad thing. We dilute ethanol with water to make it a 70% solution. We do this because 100% is effective at killing, but it evaporates too fast. Therefore, if the reagent need to stay on the surface for 3 minutes, 100% will not be adequate because it will evaporate before the 3 minutes has transpired. We currently use 70% ethanol to swab the skin prior to injections. Heavy metals will fall into the low category. Metal ions are antimicrobial because they alter the three-dimensional shape of proteins, therefore inhibiting the function of the protein, such as enzymes. Some examples of heavy metals are arsenic, lead, mercury, cadmium, copper, and chromium. One example of a heavy metal that can be used is 1% silver nitrate. This solution can prevent blindness to infants because it will be placed in the eye of newborns and it will destroy Neisseria gonorrhoeae. Another example of a heavy metal that is used is mercury-based thimerosal. This molecule is going to help preserve vaccines. When a vaccine is transported throughout the world or throughout the countries, it must be in a solution that helps to inhibit microbial growth. Another example of a heavy metal is copper. Copper interferes with chlorophyll. So any organism like cyanobacteria or algae that contain chlorophyll, this will disrupt its growth. So it is used in fish tanks, swimming pools, and water storage tanks. Another heavy metal is lead. Lead has been shown to cause neurological damage to humans, especially newborns. Brass and copper will impede bacterial growth, while aluminum and stainless steel will let the bacteria run rampant. The next germicide is phenols. Phenols and phenolics. Both belong to the intermediate to low category. They will denature proteins and disrupt the cell membrane. They have a disagreeable odor and possible side effects. And sometimes they irritate the skin in some people. In the picture below, we have the structure of phenol. Phenol is a benzene ring containing a hydroxyl group. This phenol has both antiseptic and disinfectant properties. Phenolics are phenols that have been chemically modified with the addition of halogen or organic functional groups. Phenolics can be found in natural oils like pine and clover. Remember, these phenols were originally used by Joseph Lister. Both are commonly used now in the healthcare setting labs, and in homes. They are effective in the presence of organic extraneous matter, and they will remain active for prolonged times. Bisphenolics are composed of two covalently linked phenolics. It is used to make plastic. You've heard of BPA. This is bisphenolics, which are in plastics, and it can cause brain damage, especially in infants. Two examples of bisphenolics are the active ingredient in Lysol and Triclosan, which can be found in garbage bags, diapers, and cutting boards. Chlorhexidine is a compound that contains two phenolic rings and chlorine. It has mild effects as an antiseptic, low toxicity, rapid action, and no deep penetration. It is used for skin preps and hand scrubbing. The next category is halogens. These are germicides that will be placed into the intermediate category. Halogens include four very reactive, non-metallic chemical elements: iodine, chlorine, bromine, and fluorine, all which can damage enzymes via oxidation or denaturing. The first one is iodine. Iodine tablets can be used to purify drinking water. Iodophore is an iodine-containing compound that slowly releases iodine. This degerming antiseptic is used to prep skin. You've heard of the compound benzene. This is a iodine-based compound that's used to prep skin. Benzene. Another halogen is chlorine. Chlorine can be in liquid or gaseous forms. Chlorine gas treats drinking water, and in liquid form, it is in bleach, sodium hypochlorite. Chlorine dioxide gas is used to disinfect large spaces contaminated with anthrax. In 2001, someone mailed anthrax spores through the U.S. Postal Service. This chlorine dioxide gas was used during that time. Chloramines contain chlorine and ammonia. It is used in wound dressing. The next halogen is bromine. It is used to disinfect hot tubs. The next halogen is fluorine. Fluorine interferes with sugar-eating bacteria like Streptococcus that is found in the mouth. So this halogen will help prevent dental caries. The next reagent or germicide we will discuss is surfactants. Surfactants are surface active chemicals that dissolve in water. They dissolve in water because they have a hydrophobic and a hydrophilic portion. The hydrophilic is attracted to water. Once this surfactant is dissolved, it lowers the surface tension of the solvent and increases the solubility of the organic compound, which is the solute. This makes the water more effective at dissolving the solute. Soaps are a type of surfactant that is obtained from animal fats. The specific fat is a glyceride, and it has a hydrophilic and a hydrophobic end. These soaps are good at degerming, but not good at killing the bacteria. The hydrophilic portion of soap is created because of acid anions such as CO2 or SO2. Soaps form insoluble calcium and magnesium salts in the presence of hard water. This creates soap scum. So to avoid the creation of soap scum, some people use surfactants, synthetic surfactants. Several microbes can live on soap. Pseudomonas can survive and even grow. Others that can survive are Klebsiella, Serratia, and Enterobacter. Surfactants are classified based on hydrophilic head groups. They can be into one of three categories: anionic or cationic or charged groups, non-ionics, or amphoterics. So the first two are charged. Anionics are negatively charged, and cationics are positively charged. The anionics are used in laundering, dishwashing, and shampoos. Non-ionics have no charge. It's used in fabric washing detergents. And the amphoterics have both positive and negative charges. These are used in shampoos and cosmetics. Quaternary ammonium compounds, also called quats, are also surfactants. They are popular synthetic detergents which are composed of a ammonium cation. Quats are colorless, tasteless, harmless to humans in low concentration, and they are antimicrobial. You would typically find these in foaming mouthwashes. Aldehydes are another type of germicide. These compounds contain terminal CHO groups. They cross-link with amino, hydroxyl, sulfhydryl, and carboxyl groups to denature proteins and inactivate nucleic acids. One example of an aldehyde is formalin. Formalin is composed of 37% formaldehyde and water. Formalin is used in embalming and disinfecting rooms and instruments. Another example of an aldehyde is glutaraldehyde. Typically, concentrations as low as 2% can be used. And it is very low concentration, but at short exposure, it can disinfect. Long exposure, it can sterilize. Gaseous agents will denature proteins and cross-link functional groups of DNA. These gaseous agents can be hazardous to people. They're often highly explosive, they're extremely poisonous, and they also can potentially cause cancer. We will talk about three types of gaseous agents: ethylene oxide, propylene oxide, and beta propiolactone. All are used in closed chambers to sterilize items such as plastic labware, mattresses, pillows, catheters, and so on. In this image below, you see a chamber that can be closed, and then these gaseous agents can be used. Ethylene oxide additionally can kill endospores. Oxidizing agents kill microbes by oxidation of enzymes. Oxidation of enzyme would be to remove electrons from the enzyme. This category of germicide contains three examples. It falls into the high category of disinfectants. The examples are hydrogen peroxide, ozone, and peracetic acid. Hydrogen peroxide can both sterilize and disinfect. If the microbe has catalase, then this enzyme can neutralize hydrogen peroxide. When this occurs, bubbles will be produced. Ozone is used to treat drinking water. It destroys the microbes and viruses in it. Peracetic acid is a very effective sporicide that is used to sterilize equipment.